So today topic is the support vector machine. So it is a supervised machine learning algorithm that classifies data by finding an optimal line or hyperplane that maximize the distance between each class in an n-dimensional space. You can see I have successfully write this basic library. Now for the projects, I want to load the data. So data loading, load the data. So how we can load this? So like df. So firstly, I want to provide how we can load this kind of the data. So I want to go back to there and firstly to upload the data and like SVM, this data set. So it will upload the data. You can see the universal bag data set is there. So now in Google Colab, I want to basically fetch out this data like df pd read df, like any code you want to, but you have to supply the name like the universal bank. And now the df dot head. So you can see the data is successfully displayed regarding the bank. So if I'm talking about the universal banking concept, so this is the data like id, age, experience, income, zip code, family, education, mortgage, personal loan. So this is the banking data, universal bank. So now I want to perform some EDA process, then I will apply some data pre-processing task. So now the question is that like once I have upload, so now I want to perform some data pre-processing work like the univariant and the bivariant analysis, like to check out how many null values are there, like to check like is null and the sum. So like I want to check there is any null value in my data set or not. So there is no null value. The data is very perfect. Like df dot is null. So after applying this one, I also want to drop some particular column. So how we can do is, so I want to drop like some column, like those are not real ID and the zip code. So as per your need, I want to drop this particular column from the banking concept. So also firstly, uh, like df1 dot columns. So it will show all the columns of these data sets. So now I want to drop some column like ID. So you can see like df dot drop. So drop is a function basically used to drop any particular this code like ID, zip code, axis one. So axis one basically indicate or it will work on the column. Like you want to drop the column and in place true, that means it will work on the permanently. And to pass which column you want to drop. So after drop this one, now I want to overwrite the data like df1 and df1. You can see I have successfully uh, dropped the column like ID and the zip code. You can see in the above the ID and the zip code is there. Now you can see I have dropped the ID and the zip code from my data set, and I will store into the further new variables. So now I want to find out some data correlation. So we know very well like how we can find out the data correlations. So the data correlation. So we know very well like the DF1 and the ORR. Coil RR, that is a correlation functions basically used to find out some correlations. So whenever you want to run this, so it will convert all the data into the matrix. Now you can see the age is 1, and age experience, age income, age family, age CCV, age mortgage. So it will compare all the value of the age like the 99% the experience, the age, and the income family. So now this data it is not understood into the numeric format. So I want to visualize this data correlation concept in some chart like heat map chart. So now I want to use the heat map chart for data correlation. So now I want to visualize this data into this manner like heat map df1 dot correlation and the annotations. So once you run this command, very nice. But you can see the data is there, but it is not clear. So I want to define the size of the chart like PLT figure size 10 by 10. You can see now the data matrix is it is clear. And also I want to clear out some value like as per the C map. You can see I have successfully applied this data correlation chart like heat map. So now I want to basically to define like the age is there, experience is there. So it will find out like the value, all the value show into this matrix. Now, so now I want to separately fetch out the data, any specific data because as per your requirement you want to fetch out. So now I want to basically plot the data, the basically the colors are there, the income basically. I want to discuss some data related to the. So I want to show income like show income versus experience using scattered plot. So if I want to use the PLT, so also the figure size, and I supply the income and also the experience. So if once I will apply this code, so you can see there are the huge chart. It is not understood. So similar, I want to give some coloring name like colors basically as per the requirement like red. Now the similar I want to fetch out the similar but to the different. If I want to fetch out like the green, and also I want to use the title, then PLT show. So now you can see the data is overlap. Why data is overlap? Because if you want to show the two chart into this scattered plot, so now I want to use some naming convention. So like whenever we want to show the data, so now I want to use like zero class and to pass the data. So now what is the zero class? So firstly I want to fetch out the data above. So like credit card. So you can see the DF1 dot like credit card. If you want to show only this data, so you can see we have the data into the 0 and the 1. Like credit card is 0, that is no credit card. Credit card is yes, that is indicate the 1. So I want to store this data into like no credit card, like DF1. And the DF1 inside the DF1. So not to pass directly, and to pass the DF1 dot credit card equal to 0, and also the yes credit card equal to 1. Now you can print this data. So how many credit card in yes and how many credit card is no? So the no credit card, that means this one, and the number of candidates like those have the credit card like 1470. So now I want to visualize this data here, like credit card, and we can pass the data according to this one, like credit card and the income 0. So now I want to discuss like the yes credit card. Inside the yes credit card, I want to supply the column, and similar the yes credit card, I want to supply the experience. So once you supply these particular things, now you can see I have successfully I remove the coloring concept. So it will automatically identify, no need to supply the coloring. Like those basically the credit card into this one PLT. So you can see the data into the income and the experience. The credit card, that is this one, and the not credit card, that is this one. So that is the thing to visualize, like those employee have the credit card, like yes or no. Like the credit card, no, that is 0, yes, that is indicate yes. So it is all about to visualize the data into the of the credit card. Basically those have the credit card, yes, and the no. The new things like similar, I want to visualize some advanced concept, like also to similar to visualize the average, like average versus family using scatter. So how we can do this? We can firstly like plt dot scatter. So dot similar I want to use, and the no credit card basically, but I want to supply like the column C average, and also I want to similar to check according to the family. So yes and the no. So I want to perform like this analysis, but you can see this analysis into this one. So what the data is saying, what is the C average basically. Okay, so now you can see the C average, CC average, like 1.6, 1.5. According to the family, I want to display like those have the credit card, yes or no. So I use the scatter, but you can see the no credit card, that is this. The credit card limit this. So after applying this code again, I want to scaling the data. So what is the data scaling? Firstly, I want to discuss. I have already scaling, like I want to remove some mean from the data, like the scaling the data. Scaling the data. So I have successfully defined here like scaling of data, like standardized feature by removing the mean and scaling to unit variance. So that means now we want to remove the mean. So before scaling the data is there, and after removing this one, so now the data is there. Now I want to apply the machine learning standard scaling technique, like scaling the data. So I want to use the scikit-learn dot pre-processing, and also use the standard, not the PC right now, and scalar. After scalar, like standard. So now I want to apply this scale data. Like I want to fit the scaled value and want to transform the data. So how we can do this, and also we want to draw like scaled. So now I want to use scalar dot fit function. Now I want to drop one column, like df1 dot drop, and the particular column like the credit card. So once I have successfully dropped the column, and I also want to supply the column like x is equal to 1. And now I want to transform it, the data, after applying, like x is now. Transform the data, and this one, like df1 the dot drop credit card. And once you have successfully dropped the data, now I want to convert into this, because if you I want to visualize this data, so it will be shown into this manner. Now I want to show this data into the tabular format, into the data frame. So how we can use this? So pd dot data frame, like the data frame, df is scaled equal to this one, like data frame scale value column which you want to define. Now you can see all the data are shown into the tabular format, like age, experience, income, family, cc, average, education, mortgage, personal loan, security. So now I want to basically implement the SVM, support vector machine learning algorithm. So firstly, I want to split the data. So like I want to implement. So implement the SVM. So firstly, I want to split the data. So split the data into train and test. So how we can use this? We know very well. This is the perfect model train test split. So the train test is split package, sub package will automatically split the x, y. So we know very well, like I want to split the 70% data and the 30% data. 70% data is a like population data and the sample data. And it is your choice, like you want to take 70/30 as per your requirement. And the random values it is also. You can set any random value like 1 0. So I set 1 0. So once the data is successfully split, we can also show the data set. Like if I want to print all the data sets, say, like you can see, it is the training data set and the testing, the ratio of the data set. So now we can apply the SVM. Like so, how we can do this? like from scalar dot uh, model selection. Now I want to import, and also like not the grid search. Basically I want to use simple the SVM, and not to apply directly, and also to check the accuracy. So from scikit-learn dot matrix. Now I want to import the accuracy score. Basically we need the accuracy score later. So once you apply this accuracy score and apply the model, like model equal to SVC, and to fit the X training and the Y training data set, and also we want to predict the value and to check the accuracy, like the accuracy tester basically. So now I want to execute this particular code. So my code accuracy is 75%. So again I want to show you what the accuracy 75%. This one. So when we are when we want to like linearly split the data and linearly solve the problems. So what is your work accuracy? My work accuracy is 75%. So I have successfully write the, so whenever we want to use the confusion metric, so it is a performance evaluation tool in machine learning, and to classify the accuracy model and display the number of true positive, true negative, false position, false negative, or like false positive. Now I want to show the confusion matrix. So confusion matrix. So I want to use the scikit-learn matrix import confusion matrix and want to test y test the data and the predictions. So y test we know very well the y test and the prediction. So I use the accuracy score. Now I want to display the y test and the prediction into the matrix. Confusion matrix. So the confusion matrix basically show the data into 10 this one. So what is the use of this one? So I want to use the chart like heat map chart. So confusion matrix I want to use. You can see I have successfully used this chart, heat map chart, to show the confusion matrix. So what is the value like 1.1, 11, 62. So if the number is greater than high, so you can see the value is less, so the dark. Value is up, so you can see I have visualized this data. Again, I will increase the size of this one, like the accuracy is this one, so like 2, so 20%. So you can see the training data set is reflecting training testing. So the accuracies also are reflected, and also the confusion matrix will be reflected. So now I want to use a format like FMT equal to D, and also I want to use some color map like blues. If it is your choice, like which color theme basically you want to use. It is blues. Now you can see the dark color show the positive accuracy, like positive prediction, and the less basically show the less. If you want to add some label, so you can also add the label into this. So now I want to check again, and I want to provide the like confusion matrix CMF and matrix and PD dot data frame. So I want to supply the data, complete data basically of this. And I want to supply this data here, data frame CMM, actual no, actual yes, predict yo, predict yes. And this confusion matrix, I want to provide this data here. Now you can see I have successfully used the label. So predict, and we can give the data like actual positive. You can see I have successfully labeled this value like index value and actual negative. So you can see that it is actual positive and it is actual negative. So the actual positive, the predict positive, and the negative, and it is also the negative. So now again I want to classify the report. So the report classification basically, classification report. So from I want to use the classification report like scikit-learn matrix import classification, and I want to predict complete report like precision recall F1 score support. So the accuracy is 77%, which I have already discussed previous, like 77, and like 73122. This one is a macro average, is all these things, and the weightage average. Okay, so I have write down the precision recall F1 score support vector. So what is the basically the use of this precision recall F1 factor and the support? So I have wrote. So precision used to what percentage of your prediction? So the prediction is 77%, 91%. So the negative and the positive. In the positive we have the 90%. And also the recall basically percentage of positive cases did not match. So the 99% the negative and the 16% for the positive. And the F1 factor, what percentage of positive prediction was correct? 87% and the 27. It is the 0 and negative and positive. And the support the actual occurrence of the class predict the data set like 735 0. So 731 735 and 265. So now I want to basically use SVM kernel functions. SVM kernel functions. So the support vector machines use kernel function to perform classification and regression analysis, to classify the data and to analyze the regressions. So SVM are popular supervised learning algorithm that can perform both linear and the non-linear. So it can be work with both linear and non-linear. So the kernel tick allow SVM to handle non-linear data by mapping data to high dimensional space where it better linear. So the kernel basically help to handle the non-linear data, and it will map the high dimensional space to become linear. So how we can easily? So I want to make them a picture basically. So now you can see I have successfully imported the image like types of kernel functions like polynomial kernels, Gaussian kernel functions, sigmoid, linear, hyperbolic, graph, string, and the tree. So these basically is type of the kernel functions. So how I can apply? So firstly, I want to apply the linear. Some useful kerneling functions I want to apply here. So like if I want to use the code, how we can do this? So now I want to apply the first concept linear kernel. So this is the accuracy of my test with the help of classification report SVM. So I want to check the this classifications like linear, like apply SVM model using linear kernel. So I use the again SVM, and but firstly I want to fit the data, not I want to use this one. So how we can use the data? So I use the linear classification and SVC and the kernel basically is linear. Now I want to fit the training data set, X train and the Y train. Now I want to print, so now I want to print uh, the data basically, and also the Y predict. So Y predict basically linear classifications predict Y test. Then what is my accuracy? Print classification report normally or with the help of accuracy score. So what will be the output? Like Y train is not exist, so that is the reason. So I want to X train and the X test. So now the accuracy is 76%. Why I have used the X train? Because I have already defined this data set here, like training and the testing data set. So this is the linear, like 76.6. Now 77 normal. So I want to visualize this data into the confusion matrix. Confusion matrix, similar, same, and heat map, same. So this is all about like 0 and 1. And similar to change this value, basically I have wrongly, it is 0 and 1. So I have wrongly uh, changed the value. So actual, it is 0 and 1. 0 and 1. Positive. So labeling part is, it is your choice. If you want to make them label, so the automatically like CMF matrix. So actual, now it will predict the value according to mine. So the confusion matrix. So the labeling is depend on you. So here the labeling is basically show the 0 and 1. So the positive and the negative. Now again I want to predict the result, like classification report. And I want to check all the classification. Now the classification is almost same into the linear kernel. If I want to apply some other like Gaussian radial basic formula, so you can see the Gaussian radial basis formula. So to compute the similarity score between data points on their distance. Now I want to apply the model. RBF kernel. So if I want to use any RB, so you can see I have used the RBF and fit the train and the white X train, Y train and the predictions, and then to check the accuracy. So now the accuracy is 773 and above accuracy is 768. So the linear accuracy is little bit high as compared to this Gaussian, because it will to compute the similarity score between the data point according to the distance. If similar, I want to visualize this kind of the data into the confusion matrix. So you can see this is the confusion matrix of this. 42 and 42. Now it is the 46. So some little bit changes into the this Gaussian basis formula. Now I want to discuss. So now I want to discuss the polynomial. So that represent the similarity of vector training sample, like the similarity of vector and the space over polynomial of the original variable. So it is also allowed to learning of the non-linear model. Let's see, I want to apply. So you can see I want to apply the SVM model polynomial. So again the kernel type is poly and the number of degree I want to specify the 2, and after applying this I want to check the accuracy. Now the accuracy is little bit 774 and the accuracy here 773 and the 76. So little bit accuracy is similar to the linear. And if I want to apply the confusion matrix, and the confusion matrix, so this is the data set inside this confusion matrix. And like one more kernel I want to apply, like sigmoid. This is also used into the neural network. This is a very important sigmoid. So you can see it is the sigmoid. Sigmoid we know very well. It is also the support vector machine, handle data with non-linear. And kernel function basically method used to take data and input and transform it into the required form of processing data. So let's say I want to apply again the sigmoid SVM. So now I want to apply the SVM model using the sigmoid kernel. So what will be the output if I want to apply the sigmoid? So the sigmoid accuracy it less as compared to the above, and the confusion matrix like classification report. This, so the sigmoid accuracy is less. This one. So this is basically if I'm talking about all the things from the starting. So firstly, I have discussed. So now in this topic, I want to explain the overview of the entire journey of support vector machine in this video. So let's see, I will discuss the supervised learning type. SVM is a supervised learning. Supervised and unsupervised learning, you know very well. And it will work basically optimal line or hyperline that maximize the distance between each classes. So the maximum margin, so the distance from the each classes. Then we will check like the type of SVM, linear SVM and non-linear. So how we can implement the support vector machine in linear and the non-linear. And firstly to load some files basically. And I have already loaded this data universal bank here. So once you have loaded this number of useful libraries and the data, then to find out the null values and to number of columns and to drop some columns as per your requirements and to find out the data correlations and to show the data correlation into the heat map chart and also to check out like those have the credit card yes and no, and to visualize this data with the help of a scattered plot like basically the relationship between income and the experience. So who is basically use the most credit card like yes. So the yes basically the credit card is this and the credit card no this. So after that to apply some different columns to find out like basically those are using credit card and there's any similarity any relationship between the CC average and the family and to scaling the data, and after applying the scaling data and to split the data into the training and the testing training testing model. So the I split the data 80 to 20%, and then to apply the SVM model, then to show the true, false, true, negative result with the help of confusion matrix. Like confusion matrix display the number of true positive, true negative, false positive, false negative. So you can just labeling the value and the precision recall the F score. So whenever we want to visualize the summary, the classification report is there. Then type of the SVM kernel functions I use some useful kernels like linear, accuracy, and the classification, the Gaussian radial basis formulas, and the polynomial kernels, and the sigmoids. So this is the thing basically I will discuss in this video. So let's see. So if all the things are correct, so please like.